Hi, everyone. Sorry I'm running a little bit late. If I can get your attention, please. Thanks. So I'm Hank Gibser. I'm the instructor for the class. Before I get started, is it Jay Patel? Yeah. Sorry, okay. I should know him better. He's actually done the note-taking for this class 4 times and took my class. So, and I've read his notes, and they're very good. They're better than mine. Or more clear, I guess, yeah. Yes, they're better than mine. I'll just say they're better than mine. And he wanted to say a little bit about the notes.
Well, I'm glad I'm doing a good job, but I'm from the ASUC Lecture Notes program, and we're taking notes again for this class. And if you're unfamiliar with this program, basically you could buy a semester set of notes. I come in here, take some notes, convert them to like electronic format, and after my editors are done editing them, they'll be sent to you. They're a good resource, they're a good study aid, and they allow you to like listen to class instead of just like scrambling and taking notes. If you want to buy the notes, they're $39 for a semester set, but the price goes up in 2 weeks. And you could buy the notes at notes.berkeley.edu. I wrote up the website right there, so yeah. And please also don't share your subscription because we need a minimum number to continue taking notes in the class. So yeah, thank you.
Okay. The other bonus for having him do them over and over again is that it's actually happened last semester that I forgot a page in my lecture notes, and he was able to tell me what was on it from the previous year because he had it on his computer. Okay, so I'm Hank Gibser, and I want to I'll say just a little bit about myself. I went here as an undergraduate back in the day. I stayed here to get my PhD and continued to teach. So I think I know a little bit about what it is to be a student here, those sorts of things. And I have TA'd for this class many, many, many times, and I've taught this class, I don't know, double digits number of times anyway. So I don't know, that's a little bit about myself. I want to say a little bit about this course compared to other courses you might possibly be thinking about taking. This course is kind of, at least by its title, directed towards business students, although in reality what we're doing in here has a great deal of overlap with what it goes on in the other statistics classes. Stat 2, 20, 21 are the lower division sort of intro classes. Of those, Stat 2 is sort of the most elementary. We'll do everything that the Stat 2 class will do and a little bit more. If anyone is just trying to fulfill their quantitative reasoning requirement, that class is probably a little bit more appropriate for you. Like I said, this class is a little bit more geared towards business econ students. Stat 20 and 21 are very similar. So people often ask me, like, what's the difference? The difference, I think, depends a lot on who's teaching it, but in general, Stat 20 tends to have a little bit more probability. Stat 21 tends to have a little bit more applications. So it tends to be true that people that are a little bit more math-oriented tend to prefer Stat 20, the material in Stat 20 as opposed to the material in Stat 21. But there's not a whole lot of difference between the courses. All 3 books often use the same textbook, and yes, there's definitely a great deal of overlap between them. What I do in this class that's different from Stat 2 anyway is that I will give I guess 3 handouts over the course of the semester, which will kind of give a little bit more additional material. The book is geared towards the level of Stat 2, and I think the students in this class generally tend to be a little bit better. So I do a little bit more math, a little bit more, just a little bit more material because I teach it just a little bit faster. So that's a little bit about the difference. Like I say, the Stat 20 and 21 are pretty similar, or even more similar. And when I teach that class, I sort of have a little bit of the same approach, but my handouts are slightly different, a little bit more towards probability, less towards applications. Okay, questions about any of that? Comments? Okay, so feel free to slow me down or ask questions. Today, what I'd like to do mostly is, well, about half of the lecture I'll spend doing sort of an intro, overview of what we'll do this semester, and some other just stuff like comparing the classes and whatnot. Usually take a short break about halfway through or a little bit more than halfway through, and then the last half of the class today I'll spend actually starting course material. I start this class in chapter 3, which I'll talk a little bit more about why that is, but basically I like to kind of jump into actually doing statistics. Chapters 1 and 2 are a little bit more kind of stories and examples of examples where statistics is used and maybe misused. I think the authors of the book view those chapters as sort of kind of try to draw you into the subject. I kind of feel like you're a little bit, if you're taking the class, you're taking the class, and I like to just kind of start with the material in chapter 3. I will go back to some of the stories and examples from chapter 1 and 2 later on. But that's my order of doing things. So you have your first section will meet next Monday. I won't take roll in here. It's kind of too big to have that make sense, but I will have my GSIs take roll in section. I think there's no problem getting into this class. There may be some issues with people getting into necessarily the section they want. So I'll kind of, I'll have to take roll to make sure that people are actually coming, so you should come, all right? Okay, so let's see, some other courses. And yeah, so I'll talk about the syllabus. The syllabus is online on BSpace. How many people have not looked at the syllabus at all? How many people have? Never know which one of those groups is going to be bigger. Okay, so maybe half the class has. So I'll talk briefly through what's on the syllabus, some highlights and stuff. Like I said, you can get it on BSpace. So best way to contact me is my email address. It's fairly easy to remember. It's hank@stat.berkeley.edu. So if you remember it's a stat class and you remember my first name is Hank, you should be able to find me even if you forget. And I'll just say, maybe a couple words about my name. As long as you are reasonably respectful, I don't care particularly what you call me. I think that a lot of times, sort of whatever feels most comfortable to you. I think a lot of times there's a certain amount of distance between students and faculty here, especially in a big lecture class. I know, sometimes I'll run into students and they'll be sort of weirded out to be just a few feet from me. They're used to sort of watching me at a distance. I think if calling me by my first name enables you to, makes it more likely that you'll talk to me or makes it easier to talk to me, I think that's great. A lot of students feel like that's weird too, that they'd rather just call me Professor or Dr. Ibser or whatever. So, anything in that general realm is fine with me. Like I say, being a student here, I know that, I took big lecture classes. You sort of get a little bit lost in the crowd. So, introduce yourself to me or whatever. I may or may not remember your name, but I'll probably remember your face anyway. Okay, so that's that. Yeah, so I give my phone number, my office phone number on the syllabus, which is not that useful. I mean, I don't have a voicemail attached to it, and so I think the main reason I give it to you is that if you feel like calling to see if I'm in my office, like if you're around Evan somewhere and you want to chat about something, you're welcome to call, see if I'm there, stop by. But generally, my email is a better way to get questions answered and stuff like that. Okay, so yeah, my office hours are on here. In the morning, Tuesday and Thursday mornings, 9:30 to 10:30, and right after the lecture, 3:40 to 4:30. So 3:40 just to give me time to walk from here to there. You can also, if you want, just talk to me after lecture. You can talk to me during the break too, but if you can talk to me after lecture, that's preferable, because usually I feel like it's really rushed if I try to talk to people during the few minutes break halfway through class. But yeah, if you have somewhere to go after class and you want to just ask a quick question or something in the break, that's fine. Okay, the book So it has my office here and whatever. The book is the 4th edition of this book, Statistics. This is, like I said, is the book that's used for all the lower division courses. I like the book. I think it gives a good conceptual overview of what statistics is kind of all about. It's recommended reading even at the PhD level classes in the department. It's considered to be a good book. You know, the authors are in the department, so maybe it's a little bit of bias, but the book is well thought of, and like I say, it's, you know, recommended reading for these PhD level classes for students to get the intuition behind statistics, even though they may be mathematically very proficient. Okay, so like I say, I think it's a good book. It gives you a good conceptual overview of what it's all about. So it's kind of expensive, I recognize. If you can find the trial edition, that's 2 volumes, soft cover. I think that's from 2006 or 2007 was when this edition first came out, and there was a semester before the full hardback edition came out. This trial edition was used, so you might be able to track that down used cheaply. Lots of people take this class. You probably can find. It's probably, you know, reasonable to expect to find the book used somewhere. The 3rd edition of the book, I think, won't work so well for you. So I wouldn't say you can't use it, but the homework problems are somewhat different. So if you did try to use the 3rd edition of the book, you'd need to at least have a friend or be willing to go to the library to get the homework assignments. The content, what's written in the book, is not that different. They updated the examples. There aren't so much examples with VCRs anymore and things like that. It's like, you know, stuff like that is like I said, it's been updated. But in terms of the content and the way things read, it's pretty much the same, except, like I say, for the homework. So that's if you tried to use the 3rd edition, like I said, you just have to figure out how to get the homework right. Okay. Some of the homework assignments are the same. Some of the sections of the book haven't changed, but some have. So, okay. So the grading for the course will be based 15% on homework, 10% on quizzes, 25% on one midterm, 50% on the final. The quizzes, well, I'll just maybe address the overall grades first. Statistics classes in this department are curved, and what that means basically is that the department has decided to avoid grade inflation by saying, okay, for lower division classes, we're going to give this % A's, this % B's, so forth, and try to maintain that from year to year. So those percentages roughly are 20% some kind of an A, 30% some kind of a B, 40% some kind of a C, 10% some kind of a D or an F for this course. That's not kind of in stone, but I have found that I feel like it pretty much makes sense. I feel like there's a fairly, at least for the D's and the F's, that it usually ends up that I feel like roughly 10% of the class deserves some kind of a D or an F. Okay, so, you know, not to be mean or anything, but that, you know, that's sort of what I have observed and felt like over the semester. It seems to be about right. For the A's, B's, and C's, I mean, it is a little bit arbitrary, but I think it does make sense to sort of, in a big class like this, to kind of maintain some continuity that different professors give roughly the same percentage of A's, B's, and C's. Okay? So, any questions about that part? Just the grade distribution, curving, all that. Some people say, you know, does the curve ever hurt you? I think people are maybe used to thinking that if you get more than 90% of the points in the class, you should get some kind of an A. And then if you didn't, you might feel like the curve hurt you. That's never happened as long as whenever I've taught the class, although it's been sort of close sometimes. So, you know, roughly, if you do get about 90% or above of the total points, you should, you know, I would expect that you would get some kind of an A. And that number usually ends up being in the mid, high 80s, somewhere in there is where it actually ends up being cut off for the A. Okay? So, other questions? Okay, so that's a little bit about the breakdown of the grades and all that. I'll say a little bit more about the specific sections that you'll do. The homework will be due in section, beginning of section. I don't want people to be, go to the section expecting to do their homework during that time. And I'll drop your 2 lowest homeworks. And so no credit will be given for late homework. But so officially, no credit for late homework. If you can, talk to your GSI, make arrangements, hand it in later that day, stuff like that, I'm not going to tell them not to do that, okay? But I don't want to sort of get in the, I don't want to, and I don't want them to get in the business of trying to evaluate how good your excuse is, or how late is it okay, and stuff like that. To be consistent, I'd like to just say no late homework. Although, if there's like something that, if you can talk to your GSI beforehand, get it in that day. If you forget it at home, stuff like that, you might be able to hand it in, but no promises, okay? So that's the homework. Okay, yeah, so solutions will be posted on the 3rd floor hallway of Evans Hall. Your discussion sections are in classrooms in the middle of Evans Hall, and I'll just give you a little bit of insider information about how the numbering works. If you've ever gotten lost in Evans trying to find a room, the one thing that's confusing about the numbering system of the rooms in Evans is that the odd-numbered rooms are all on the outside of the building, meaning that they have windows. The even-numbered rooms are all on the inside of the building. They don't have windows. So, like 349, my office, is not particularly close to like 344, for example. So it feels a lot of times like, well, I found this room. I found room 9, where's room 10? And maybe somewhere completely different. So there is a logic between the odd and the even numbers. I don't know if this was designed by some crazy mathematician or something, but in any case, you should have that in mind. So the classrooms are all even numbered rooms. They don't have windows. And they all are in the center hallway as it happens. So if you're looking for your classroom, that's where you'll find it. And yeah, that numbering system is true on pretty sure all floors. Definitely on the ground floor where the classrooms are, and on the 3rd floor. Even numbers in the middle, odd numbers on the outside. Okay, so let's see. Yeah, so the solutions are posted in that middle 3rd floor hallway where your discussion section is. It's labeled lab section. It's not like you're going to do any experiments or anything in there. It's really a discussion section. So there are some glass cases there, and one of them is labeled or will be labeled with my name in this class, and I'll post homework solutions up there. Probably the day, probably the day after, either the day after or the Thursday after. So they're due on Mondays. I'll post them either Tuesday or Thursday. So the quizzes are on the schedule that's on the syllabus. So something that's often confusing is that the quizzes are take-home quizzes, okay? And the way the quizzes will work is that they'll be posted on BSpace on the date that's given on the syllabus, okay? So that's when you can start them. They're due in discussion section the following Monday, so you have a week, okay? So there's sort of like maybe extra homework. And the reason why a couple of reasons why I do it this way. One is that the problems in the book are often not as hard as the problems that I give on exams. And I mean, the reason for that basically is that if I gave problems that everyone could do, there'd sort of be no point in giving the exam. And so I try to make the exam hard enough that some people will miss problems, and the grades will be, or the scores will be some determinant of what people know. So the quizzes will also tend to be a little bit harder, to be a little bit more towards exam preparation. My intention with the quizzes is that the reason why I call them quizzes instead of sort of extra homework is that I think you should try to do them in something like an exam situation, okay? So you should, it'll be material that, it'll be a little bit harder. So you shouldn't expect to get them all right, but I think that should be your attempt. And the way they'll be graded is that you'll be given a score, like a raw score of how much you got right, so you can see what you got right and wrong. But in terms of the grade that will go towards your course grade, your letter grade, you'll basically be graded on whether or not you did it or not, okay? Now, when I say did it, I mean like really attempted it and like, did it. And what we're going to use as a measure of whether or not you really tried is whether or not you can get more than a quarter of the problems, okay? So the bar is not that high in terms of like, you need to do it, but you do need to try hard enough to like, get a quarter of it right, okay? So if you do that, you'll get full credit. So if you get at least 25% on a take-home quiz, then you get full credit in terms of your letter grade. If you hand it in and you get less than that, if you get less than 25% of the points on the quiz, you'll get half credit for that take-home quiz. If you don't hand anything in, you get 0, okay? So, do them and take them a little bit seriously, but also I think it's good to try to, it's intended to be a little bit of an opportunity for you to test how well you know the material, right? When you do the homework, you use the book, you do all that kind of stuff. It's not really like an exam situation. So that's an opportunity to sort of see how you're doing. Okay, any questions about the take-home quizzes? Okay, so that's that. Okay, so then the midterm and the final exam dates are on here. I'm sorry, the final exam date is not on here, I'm sorry. But you can figure out what it is. It's whatever it says in the schedule of classes. The midterm's on here, and for a class this big, it's not really practical to give earlier or late exams. The class is curved, so I don't really feel comfortable giving you a different exam and then comparing to the rest of the class, and I don't really feel comfortable giving you the same exam that everyone else is taking on a different day. So make sure that you can come to those exams, okay, that there are no conflicts. If you have to miss the final, probably what will happen is you'll get an incomplete. So you can retake the final for a future semester. It's also possible, we should talk about it, possible that you could take the final for the other course. We should really make sure that works for you. That obviously taking a different professor's final is not really ideal, but it's a possibility if there's really no other way to get around it. Okay. Calculator is not, any big fancy thing. You need to have a calculator that will do a square root, and you don't need it to do anything else. Whenever I care, I'll ask you to show work on exams. So if you do have a fancy calculator that do all kinds of neat things for you, that's great. If you can figure out how it does everything, that's fine, but I will ask you to show your work. So you will need to understand the steps involved in getting answers anyway, okay? I guess I skipped a little bit about exams, just that at least a week before the exams, I'll put a study guide on BSpace that will have old exam problems, answers, and it's kind of an outline of everything we've covered, at least what chapters, what sections of what chapters, and all that kind of stuff. So you can use that to study. Okay, and some comments I make. So you can read the comments if you want, when you get the syllabus, but I think the thing I want to maybe emphasize is that, well, a couple things. One is I think it's useful for you to get as many opportunities as you can to learn the material. So one opportunity is watching me do stuff in class, okay? One opportunity is reading the book. One opportunity is doing homework. That's sort of the maybe, kind of obvious stuff. I think it's also very valuable for you to study with other people, to try to teach other people things, explain things to people. If you can get someone to listen to you talk about this class that's not in this class, I think that's a really good test of how well you understand the material, if you can explain it to someone who isn't in this class, okay? I think the Student Learning Center is an excellent resource. I think we'll have someone from the Student Learning Center talk about that, next lecture or the one after that. And I know a lot of times students will just kind of go there to do their homework, and then you meet other people in the class. You can study together. You can work on your homework together. If you're doing your homework there, obviously there are tutors there. I don't know if you know that. There are drop-in tutors in the Student Learning Center, and you can ask them questions. They're people that have taken the class, so they're generally pretty good. So I recommend that as a resource. As we get closer to exam times, you might also think about things like trying to anticipate things that I might ask, trying to make up questions along those lines, and maybe sharing those with your friends and trying to see, if you can do each other's problems and stuff like that. So in that same vein of like trying to get as many opportunities as you can to learn the material, I think if you read the book, or at least sort of skim the relevant sections before you come to lecture, that gives you an additional opportunity. And then what might happen is that if you read the book a little bit ahead of time, you can kind of at least identify the things that you don't really know so well. And then when those things come up in lecture, you sort of pay extra attention and catch those loose ends that you didn't get when you were reading or skimming the book. And then when it comes time to do your homework, maybe you could just do some of it without even really reading the book again. I think if the first time you read the book is when you're doing your homework, that's sort of not ideal. Okay. Now, this is sort of my advice. You take the course however you want. I realize you don't have all the time in the world, other things you want to do or need to do, and so it might end up that a lot of you do end up just reading the book as you do the homework. But if you want to get the most out of the class, learn the most, I think it is nice to look at the book before lecture. So to enable you to do that, I've put on here on the schedule what sections of the class, or what sections of the book I'll be lecturing on for each lecture, roughly. Now you can sort of see as you, based on where I stop, figure out where that is in the book, and then, sort of move ahead. And I may be a little bit ahead or a little bit behind the syllabus at times, but more or less, this is where I expect to be. Okay, so there is a schedule. It gives, like I say, what's on the what each lecture will be about. There are handouts that I'll put on BSpace. I'll lecture on those handouts at times. And what was I going to say? Yeah. I don't know. I lost my thought there. One other thing I feel like I should tell you, or maybe warn you on a kind of personal level, is that my wife's pregnant and due during spring break. So these things, they're not exact. So it might be at some point that I miss a lecture or two. I'll try to have a sub, but if it's like my wife goes into labor at noon or something on a lecture day, I'm not sure how possible that's going to be. It's possible that I'll miss a lecture right around then. So just that's a possibility. And I'll try to put a note on BSpace if that happens. I think that much time I should be able to spare between contractions or whatever. Okay, so that's that. Okay, so I think that's basically everything I wanted to say about the syllabus, and kind of course logistics and all that. Does any questions come up for anybody? Yeah. Midterms are closed book, and you can't bring anything except for a calculator. Calculator and something to write with. You don't need a blue book, so just write on the exam. Yeah. Yeah, so I'll give a study guide a week or so before the midterm and before the final. That'll have a lot of old problems, and yeah. Okay. Any other? Yeah. Yes, thank you for bringing that up. So homework is graded for accuracy. So actually the homework is, I guess I've made it worth a little bit more than the quizzes. A little bit for that reason is that there's a grader. It's not a GSI. It's someone who's taken the class and done well, who will grade your homework and give you a score, which is just a score, however much you get right, however much you get wrong. So yeah, so your homework is graded for accuracy. So probably if anything, you want to be a little bit more careful with your homework than with your quizzes. Like I said, my intention a little bit more with the quizzes is to have you be able to use it as kind of a self-test. And that's typically the problems will be a little bit harder. Okay, any other questions, thoughts? Yeah?
Are you curved by midterm or at the end of the?
Yeah, so the way the curve will work is at the end of the semester, I'll figure out a total number of points for everyone in the class based on this breakdown: 15% homeworks, 10% quizzes, 25% midterm, and 50% final. So everyone will get kind of an overall score for the course. And I'll just rank everyone in order. And then, like I say, roughly, I'll start by chopping off, okay, top 20% of the class, that's some kind of an A, next 30%, some kind of a B, 40%, some kind of a C, and sorry about the last 10%. So that's sort of my starting point. Then I kind of look at the borderlines, and I don't like to, if two people are very, very close in their scores, I don't really like to give them different grades. So I'll look kind of around there for gaps. So I'll maybe be a little bit kind and maybe bump up a person or two that has a score very similar to the next score. Or like the last A minus has a score that's almost exactly the same as the first best B plus. Stick a couple of B pluses up maybe to looking for a gap of at least a little bit of a bigger gap. With a class this big, there aren't really big gaps. Scores are pretty spread out. So but to the extent I can, I'll try to do that. And then I'll sort of assign pluses, minuses, and regular grades according to the same idea. Roughly a third of the class gets a plus, gets a minus, gets the regular straight grade. Except I sometimes tend to give a fewer A pluses. I kind of feel like A pluses are special. So sometimes maybe about a third, but tend to be, if anything, a little bit fewer than that. Okay, so what was your question? Did I answer your question?
I mean, like when we get the midterm back?
Oh, yeah, okay, yeah. So I won't give you a letter grade explicitly on the midterm, but I will tell you what the 80th percentile is on the midterm. So we'll talk more about percentiles in detail later, but basically 80th percentile means that you did better than 80% of the class, right? So if you're above the 80th percentile, that sort of means you're in the top 20%. You're sort of on track to get some kind of an A, okay? So I'll give you some, some of the major percentiles like that after the midterm, so you get some idea of how you're doing compared to the rest of the class. I won't do that for homework, and I'll just say, most people in this class do the homework and do fairly well on it. So it tends not to help you that much, even if you do really well in the homework, because a lot of people do really well in the homework. Which is not to say you shouldn't do it. It can certainly hurt you a lot if you don't do it, because if everyone else is doing it and you're not, then you're just losing this chunk of your grade that you could be getting. And same thing with quizzes, that most people tend to do all the quizzes. So it's not going to, if you have done all the quizzes and gotten 100% on them, you shouldn't look at that as being like, oh, like I have an A+ on my quizzes. You should kind of look at it as, well, they're not going to hurt you, right? It's not going to bump you down below anyone, but it's not going to turn your B on the midterm into a B+ or an A- or something. It's not going to improve your score relative to the rest of the class, or if it will, it's be pretty slight. Okay, so yeah, the grade you get on the midterm is a pretty good indicator of how you're doing relative to the class. Okay, other questions? Okay, so let's see. Is there anything else I want to say generally? Okay, so let's it's a little bit early-ish, but let's take a little break. If you want to ask me any questions individually, you can. And when I start back up, I'll kind of give an overview of what we're going to do this semester, and then maybe at the end I'll get into the actual book. Okay, start again. Okay, why don't I get started again? You can take your seats. So, what I'd like to do for first lecture is to give you kind of an overview of what we're going to do this semester, topics and whatever. I'll spend a little bit more time on the stuff we're going to do very soon. And I think I'll have time to a little bit at the end to go into the kind of the first chapter of the book. But depending on how much you ask me questions and how slowly I go, I'm not sure if I'll get that far. But anyway, just generally, I like to just talk about what is statistics. And I kind of roughly divide it into three broad topics. The first one is descriptive statistics. And I mean, to answer the big question of what statistics is, in general, we're talking about numbers and sort of analyzing or trying to get something out of numbers. So you can try to think about it as having a bunch of numbers, data, and trying to answer some question based on those numbers. Much of it has real-world applications. Some of it is a little bit more abstract or theoretical. But in general, that's sort of the objective, is to try to answer questions based on numbers. So the first part, descriptive statistics, is kind of about foundations of that idea. And essentially, descriptive statistics are ways of summarizing data somehow. So you have lists of numbers that may be somewhat cumbersome. If I had a list of like all the heights of all the people in the room, and I handed you a sheet with all those numbers on it, it might be difficult for you to like get anything meaningful out of that. But if we can summarize that data somehow, then it might be a little bit easier to digest or answer questions about. So there are two basic ways to do that or to think about that. The first is graphical, to draw a picture somehow, which will give us a representation of those numbers or data. And the second is summary statistics. So summary statistics are numbers that summarize other numbers, basically. So let's talk a little bit about examples of each of those. So can anyone give any examples of graphical descriptive statistics or pictures for data? Anyone? Yeah. Histogram. That is, in fact, the first thing that we'll do. Yeah? A pie chart? Okay, so I'll draw like really quick pictures of each of these just to sort of give you an idea of what this thing looks like. I don't know, maybe a little bit like that. A histogram looks like that, and sort of tells you a little bit of something about the data. So this might be a picture of something like, I don't know, income, where there are a lot of people that sort of don't earn so much, and then a few people spread out that earn a lot. Okay, so it just tells you a little bit of something, a little story about the data. Pie chart typically is used to represent things that are qualitative rather than quantitative. So if you think about what's going on the x-axis here, if this is something like income, there are numbers here. So these along this horizontal axis, you have actual incomes, actual numbers. So think about what the data looks like in that case. If you have a room full of people, you have an income for each person, a number, and you can represent that with a picture. For a pie chart, typically, you're not talking about having a number for each person. You're talking about some characteristic like, I don't know, marital status or ethnicity or something like that, which each one of these pie slices represents one of those characteristics. It's not a number associated with it, but it's a picture. Both of these have an interesting characteristic, which is that the total area of each picture is 100%. Okay? So pie chart, I think that's pretty natural to think of that as being total area 100%. Histogram, maybe it's not so obvious, but it's true. And we'll talk about that in more detail. Pie chart, probably never talk about after today. Histogram we'll talk about it a lot. But mostly we're going to talk about things that have to do with data that can be represented with numbers, like income or heights or things like that, and not so much with things like that. OK? Any other thoughts, examples? Yeah. Scatter plot, good. So scatter plot is also a big topic in this class. We'll get to it a little bit later. Both of these are pictures that represent sort of one variable. Income, for each person, there's one income. For a scatter plot, each person has two variables. So you might think of this as, I don't know, something like height and weight. Each person has a height, each person has a weight. A scatter plot or a scatter diagram is a picture which represents all that data as one. So each person has a point in this picture. Plot their height, plot their weight. Taller people tend to be heavier, so that there are sort of more points, tend to be more points in the upper right and lower left. Tall, skinny people, I guess, would be down here, like especially tall, skinny people. And then short, fat people tend to be over there. Short, fat people are funny, I guess, for some reason. But sort of, most of the people tend to follow this general shape. OK. All right, so like I said, these two are for one variable. Scatter plots are for two variables. OK. Any other questions? Or any other examples? Thoughts? Yeah. Stem and leaf plot. So stem and leaf plot is not covered in this class. It essentially is it's a little bit like an alternative to a histogram in that it's for one variable, and it gives you some idea of the general shape of the data. Yeah, so that's another example of a picture, but we won't cover it. So I'll write down. Yeah, another example, yeah. Box and whisker, another example, similar box and whisker. Box and whisker tends to emphasize or give you more information about the tails, the kind of extreme values. Those are the whiskers, and the box is sort of where most of the data is. So you have the, yeah, those are both. Well, I guess box and whisker is that kind of a shape, that it tells you something in particular about what's going on in the extremes. Stem leaf. Stem leaf is a sort of nice picture, actually, because it gives you a lot of the same information as a histogram, but it also enables you to see what the raw data is. Whereas a histogram, you can't actually tell what the individual incomes are. You just kind of know what the ranges are. Anyway, those are some other examples, good examples. Anything else anyone wants to mention? OK, cool. So we hit the ones that we'll cover most in this class, the histogram and scatter plots, but these other ones are good common ones that people see. OK, what about descriptive? Or sorry, what about summary? Summary statistics. So I kind of said this is numbers that are used to summarize other numbers. Yeah. The mean, also known as the average. So we'll get to that pretty quick. Histograms are in chapter 3, which is the first chapter we'll do. The mean, or the average, is in chapter 4. So that's coming soon. I'll talk about it by the end of next lecture, I guess, or definitely by next Tuesday's lecture. So the average is what you get if you add them all up and divide by how many there are. So if I wanted to find the average height of all the people in the room, I have all the raw data. If I add them all up, divide by how many people there are, this gives me an idea of kind of loosely where the center is, kind of what the typical height is. Okay, so that's very common, valuable summary statistic. Any others? Yeah. Median, good. So median is another measure of center. It has the characteristic that loosely half the people are on either side. And you might think that the mean and the median should be the same. They don't have to be the same. They're generally fairly close. In many cases, they're equal. But if the data is kind of lopsided or skewed, these can tend to be different. Okay? For a lot of data sets, these end up being very close to each other. And when we get to chapter 4, I'll talk in a little more detail about why those differ, how they differ, why we might want to use one instead of the other one, stuff like that. Okay? But again, like this is average, just briefly, is what we get by adding all the numbers divided by how many there are. The median has a characteristic that if you, like half the points are on either side. So if I put everyone in a line in the class from shortest to tallest and found the middle person, that's the median, right? Half the people are on either side. Okay? Anything else? Any other summary statistics? Yeah. The mode. Okay, so the mode is something I won't talk about after today. It's not a particularly good, it's sort of in the same class of measures of center, but it's not a very good measure of center. So the mode is the most common value. So for example, if we're talking about the heights of people in the class, if it turns out that, I don't know, for whatever reason, there are 20 people in the class that are exactly 5 feet tall, okay? That might be the mode, but it probably is not close to where the center of the class is. The average might be, I don't know, 5'6" or something. So, you know, just because something is the most common value doesn't mean that it's necessarily a good measure of center. So that's why we won't really use the mode so much. But that's how it's defined. It's the most, like I said, the most common value. Yeah. So 95% confident or confidence interval is not itself, I wouldn't describe as of a summary statistic. That's more in the lines of what we'll talk about in data analysis, which is later in the class. So that, in a sense, is a summary of data, but it's used in a sort of different way than we use these. Yeah? Range. Okay, so the range. So the range gives you an idea of, you know, the smallest and the largest values. So that can give you a useful idea of what this, how spread out things are. So if we're talking about the heights of people in the class, if I told you the range, it gives you some idea of, you know, what variety there is in the class. If everyone's very close together, if everyone's very far apart. Yeah? Correlation. Good. So before I say correlation, there's one more that sort of has to do with spread that I'm hoping someone's going to say. Yes, standard deviation. Okay, so standard deviation is a summary statistic that attempts to sort of directly measure how spread out things are. So if I'm talking about the heights of the people in the class, the standard deviation gives us kind of a typical distance from the average. So if the average height of the people in the class is 5'6", the standard deviation is, I don't know, 3 inches. That's telling me that the people in the class generally around 5'6", give or take about 3 inches. Okay? Plus or minus about 3 inches. Some will be farther away, some will be closer, but that's maybe a sort of typical distance away from the average. And that has a lot of specific characteristics. So the mean and the standard deviation and the median are all things that we'll talk about a lot more in chapter 4 once we get there. But just briefly, this gives us a sort of an idea of about how spread out are the people. What's a typical distance from the average? If everyone in the class were exactly the same height, the standard deviation would be 0. Everyone's like right at the average. If the class has a lot of like really tall basketball players and say jockeys or something, some short people, then you tend to have a larger standard deviation, larger range, larger standard deviation. Okay? All right, so this is correlation someone mentioned. Okay, so all these have to do with one variable at a time, just like histogram, pie chart, stem leaf, box and whisker all have to do one variable at a time. Scatter plots, 2 variables. Correlation, also 2 variables. So correlation measures something that's a little bit hard to get your head around intuitively. We'll talk about it in a lot of detail starting in chapter 8. But what I'll say about it right now is it measures something about how strong the relationship between 2 variables is. So for example, in my picture here, height and weight, there's some relationship here, right? Taller people tend to be heavier. A very strong correlation would mean that the points are nearly on a line, okay? So that if I knew someone's height, I would have a very good idea of what their weight was. Very strong relationship. If the relationship is very weak, there's a very weak correlation, then knowing someone's height would not give me particularly very much information about their weight. So tall people and short people would tend to weigh about the same thing, okay? So this is somewhere in the middle. This is sort of a medium, strong relationship. Should sort of have a medium correlation. And like I said, when we talk about chapter 8, I'll do this in a lot more detail. Talk about, well, what values correspond to strong correlations, weak correlations, that kind of stuff. But just as a general intuitive thing, it's telling us something about how strong that relationship is, which is something that's nice to know, right? If you're studying the relationship with two variables, it's nice to have some summary statistic that tells you briefly what that picture looks like. Okay? Questions about any of these? Okay, so the main ones that we'll study in here: mean, median, standard deviation, correlation. Okay? You could also think about percent as being a summary statistic. We'll definitely talk about it, but it's fairly common, so maybe I won't say more about that. Okay, questions about any of this? Okay, so roughly this stuff, descriptive statistics, graphical and summary statistics, gets us through maybe the first, well, we'll do chapters 3, 4, 5. We'll skip chapters 6 and 7. Chapters 8 and 9 talk about correlation and scatter plots. So that's the, I don't know, first maybe month or so of the class. So I have a syllabus here. I can find out exactly. Yeah, about 3 weeks. About 3 weeks of the class will be on that stuff. Then we get to a part of the book which is a little bit in between. Technically, you might think about it as descriptive statistics. It's basically thinking about these pictures with two variables and attempting to predict things like weight from height. So if I told you someone's height, it might be nice to know, well, what's a good guess for that person's weight? All right? So that is chapters 10, 11, 12. It's a little bit of an extension of this idea of descriptive statistics. You might consider it to be part of data analysis, which is another one of my main topics. But it sort of is in this area. The second part, the second kind of major heading that I'll give is probability. And probability is a little bit, it was sort of a little bit change gears once we start talking about probability. Probability is slightly more mathy than other things that we'll do in the class. It's also, I think, slightly more creative. A lot of the stuff in the class will be kind of like, well, you need to memorize how to do some particular technique or method, like to calculate the average. You add up all the numbers, divide by how many there are. And then you need to know when to apply it. So you sort of learn how to do these techniques and when to apply them. Probability is a little bit harder to learn that way. So I think a lot of students many students have trouble with this part of the class. Some students find it, I think, more interesting and more fun because you're answering questions like, what is the chance of some event? Okay, so that, we'll learn certain techniques, and to some extent, you can kind of learn the techniques and then learn when to apply them. But often there's more than one way to solve these problems. So, and sometimes a method that you think will work won't work. You sort of have a dead end. And so it's not quite as straightforward, I think, as other things in the class. But I think it is interesting. And the examples in this part of the class, some of them are gambling examples. I think those often are like cards and dice and coin tosses, stuff like that, are kind of natural settings for talking about probability. They won't all be like that. You don't need to have any prior knowledge of gambling or anything. But some of them tend to be those things. So I think people that enjoy those kinds of problems enjoy this part of the class. Which is not to say that other people can't enjoy it too. But that's a little bit of the tendency, I think. Okay, so that's this kind of other area of broadly what statistics is about, but probability is often considered sort of its own separate thing. Okay, questions about that? Okay, like I said, I wanted to sort of do these first parts in a little more depth and then just give you a little brief hint of what's happening later. So that's about when the first midterm will happen, is after we finish up with probability. The rest of the class, the sort of last half of the class, is on some level data analysis. And we kind of need to do the first two parts. We kind of need to do descriptive statistics and probability in order to think about data analysis problems. And when we get there, I'll sort of explain a little bit more about why. But basically, whenever you try to analyze data, you're trying to say something about, or answer some questions about numbers in some way. In order to do that, tools you need to employ involve descriptive statistics and also involve thinking about your data in some way as occurring randomly. That, for example, you take a sample of people out of some larger population and you observe some data, but then another question might be, well, what would have happened if I had picked different people? And that process is sort of random. So you sort of need to know something about probability in order to think about, well, OK, my data was this, but what could it have been? If I had randomly had something else happen, how far off might my answer be? So anyway, that's a lot of what data analysis is about, and sort of employs ideas from descriptive statistics and also from probability. Methods we'll learn. Someone mentioned confidence intervals before. Oops. So the idea of a confidence interval is to answer questions like, well, suppose I wanted to find out what the average height is of everyone in the class, but it sort of would take me a long time to ask everyone in the class. And so I might just ask like maybe 10 people, 20 people right here, get their average, and think, well, probably the average of this group of people is about the same as the average of everyone else. The idea of a confidence interval is to basically establish a range where I'm pretty sure the average of the whole class would be between this number and this number, based on my little subset. Okay? So that's the idea of that bit of data analysis, is you can say things about larger populations based on smaller samples. Okay? So you might wonder things about like people in the whole country, and you might take a sample of, I don't know, 100, 1,000 people randomly, and then try to answer questions about the whole country based on your small sample that you can study in depth. Okay? So that's part of the idea of confidence intervals. Another concept or method is hypothesis tests, or hypothesis testing. And just briefly, the kinds of questions you answer with hypothesis tests are things like you have some drug and you do a study on the drug and you hope that it, say, reduces the risk of heart disease. Okay? So you do some study and you attempt to answer that question. So essentially, one hypothesis might be that it does nothing. One hypothesis might be that it helps reduce the risk of heart disease. And you try to decide which one of those you think is most likely based on the data, which one of those you believe in, which one of those hypotheses wins, sort of. OK, so that's a little bit about data analysis. There's a part, actually, that we'll cover along with descriptive statistics, which is called regression. So I'll put it kind of parenthetically here. You might think of this as data analysis. This is what I mentioned about it's basically the game or the idea of trying to predict one variable from another. So trying to predict someone's weight from someone's height. It's the idea of regression. And this is, like I say, this is in the beginning of the class, actually. So the way that we'll do things, mostly what I've outlined here is more or less in the order of the class, except this. This is in chapters 10 through 12. OK? So just briefly, histograms, chapter 3, mean, median, standard deviation, chapter 4. Chapter 5 talks about a specific case of a histogram, the normal curve, which comes up a lot. I haven't mentioned it yet, but it's a specific picture for a histogram. Maybe I'll draw one. Normal curve looks roughly like this. That's chapter 5. Chapters 8 and 9 talk about correlation. Chapters 10 through 12 talk about regression. Probability is in 13 through 15. There's kind of a segue in chapters 16 through 19, halfway in probability, halfway in data analysis, getting into, actually 16 through 20. And then chapter 21 starts with confidence intervals, and then at the end of the class, we'll do hypothesis tests. So that's briefly overview of everything we'll do this semester. Okay, I'm not going to let you go this early, I think. But any questions? I'll start a little bit about histograms. But questions, thoughts, any of this? Okay, so let me talk about histograms just for a little bit, okay? We still got almost 10 minutes. So what I'd like to do, I think, is give you instructions. I think maybe I'll have time to actually do draw a histogram. Squeeze this on here. Okay, so histograms. So how to draw. So if you have data in terms of counts or raw numbers, first thing you want to do is convert that to a percent. So I'll describe this and then I'll do an example that I think will illustrate what's actually going on in each of these steps. So for each bar, remember the histogram has those bars, right? My sort of little quick picture. Find width, then height. And the way you do that is that each bar is a rectangle. So we can think of height as being equal to area divided by width. So this is just, for a rectangle, the area would be equal to the width times the height. So the height must be equal to the area divided by the width. And just sort of say here, area is equal to percent. Okay, so we'll talk a little bit more about that idea. The area is percent tomorrow, but I think I will try to get an example on the board. Third step, draw and label axes. And fourth step is to draw in the bars. Okay. Oops. So I want to do this with you as my data set. So I want to collect data real quick on your cell phone usage. So think about what your monthly cell phone usage is. It can be this month, last month, a guess as to what your average is. Everyone should get a number in their heads, and I can divide you into groups according to the minutes. 0 to 200, 200 to 400, 400 to 600, 600 to 1,000, and 1,000 to 2,000 or more. Okay? I should do text messages? Well, I'm going to do cell phone usage today, I think. Maybe I should do that. Yeah, I'll just do this since this is what I planned. This is number of minutes, and we get a count here. Okay, so think about which group you're in, and I'm going to do this very quickly and roughly. I'm going to kind of estimate, because I don't want to run out of time. But 0 to 200? OK. 5, 10, 15, 20. OK, so around maybe 120. 200 to 400. About 90. 400 to 600. About 50. Don't write this down because I might change it, just because I want to make the numbers come out right, come out nicely. It's totally cheating, but yeah. 600 to 1,000. 1,000 to 2,000. Anyone? Don't be shy. I know you're not. OK. I'll call that 10. So what do we got here? This, I think, was a little bit higher, and this, I think, was a little bit higher. So, OK. I just want to make things come out nice. So this is 300. OK. So first step is to convert to percent. So out of 300 people, 130 is what? 43%. 43.3. 100 is 33%. I guess I'll put one decimal. 50 is 16.7%. 10 is 3.3%. And again, 10 is 3.3%. Okay? So these are the percentages. First step, convert to percentages. Second step, I want to find the width and the heights. Okay? So each of these, the widths are simply these like ranges, right? 0 to 200 has a width of 200, and then 200, 200, 400, and 1,000. Okay? So then the heights, remember, are areas divided by width. So these the percentages divided by the width. This is area, right? Area is equal to width times height. It's good what you have in your back of your mind. OK, so divide that by 200, and we get, what, 0.217? About, I guess I'll write 0.217. This one is going to be 0.167. This is 0.83. Wait, yeah, 0.083. This one's going to be, I guess that's, 4 is about 0.008 about. And this last one's 0.003 about, right? 1, 2, 3, yeah. OK, so those are my heights. So now I can draw it. So draw the bars, label the axes. This is monthly cell phone usage. If I missed any of my math, correct me. If anyone sees any mistakes I made. 1,000, 2,000, 2, 4, 600. OK, so I'm just drawing and labeling the axes. The heights, the units I'll talk about in detail next time, but just let me get the heights on here. So let me say, I guess, about 0.1, 0.2, 0.3. All right, so I'll talk about this more next time. But the units here are percent per minute. OK? I'll say what that means next time. OK, but I just want to get the picture. Last thing is drawing the bars. So the height of the first bar is 0.217, so that's about here. And then 0.167, 0.083, 0.008, and 0.003. OK? So like the picture that I sort of thought about for income. A few people talk a lot of minutes, but mostly people are clustered around here. This is actually the first year that I've ever had where this bar is bigger than that. The first bar is bigger than the second one. That might be because of a lot of texting and stuff. People are talking on their phones less than they used to. OK? I'll reproduce that next time, OK? And we'll talk about it. OK, see you Thursday. Ask me questions if you want.